What if I told you that some of the greatest engineering marvels in history were built without cranes, without bulldozers, without electricity, and without a single modern machine? Thousands of years ago, ancient civilizations moved millions of tons of stone, diverted mighty rivers, and constructed colossal dams that transformed entire landscapes. Some of these incredible structures still stand today, continuing to control water centuries, even millennia after they were built. How did ancient engineers accomplish feats that seem almost impossible even by today's standards? What secrets did they understand about mathematics, construction, and the power of nature? Join us as we uncover the astonishing story of how ancient empires built megadams without machinery and the timeless ingenuity that changed the course of human civilization forever. For ancient civilizations, water was both a blessing and a threat. Rivers provided drinking water, fertile soil, fish, and transportation. But they could also become deadly. A sudden flood could destroy crops, homes, and entire settlements in a matter of hours. Ancient engineers therefore faced a simple but enormous challenge. How do you make a powerful river work for you? Their answer was engineering. They built embankments to hold back floods, canals to redirect water, reservoirs to store it, and eventually massive dams to control its flow. These structures transformed dry landscapes into productive farmland and allowed growing populations to survive. But building a dam was far more than stacking stones across a river. Engineers had to understand the strength of water, the weight of stone, the stability of foundations, and the movement of floods, all without modern computers or machinery. They relied on observation, mathematics, experience, and thousands of workers. And when one civilization solved a problem, others learned from it. Across Egypt, Rome, Persia, and China, ancient engineers developed remarkably different ways to control the same powerful force. Their experiments would eventually produce some of the most impressive waterworks the ancient world had ever seen. And one of the earliest known attempts at building a massive dam took place in ancient Egypt. Around 4,600 years ago, during Egypt's Old Kingdom, Egyptian engineers attempted something extraordinary. They built what is often considered one of the world's earliest large dam projects, el-Kafara, meaning Dam of the Pagans. Located in a desert valley near Cairo, the structure was designed to protect settlements and construction sites from destructive flash floods. But this was no simple barrier. The dam stretched roughly 100 meters across the valley and was built from enormous quantities of stone and earth. Without cranes or engines, workers quarried limestone, transported it using sledges, ropes, and human labor, and carefully built the structure layer by layer. At its center was a massive earthen and stone core, reinforced by sloping walls designed to resist the pressure of water. The engineers clearly understood an important principle. A dam must not only hold water back, it must also survive the water flowing around it. But el-Kafara had a critical weakness. It apparently lacked a properly designed spillway to safely release excess floodwater. When an enormous flood eventually struck the valley, water overwhelmed the unfinished structure. The dam failed. And although the project was never completed, its failure became an important lesson in hydraulic engineering. The Egyptians had discovered something that every dam builder would eventually learn. Water always finds a weakness. Centuries later, another civilization would take water engineering to an entirely new level: the Romans. The Romans inherited centuries of engineering knowledge, but they pushed it further. Across the Roman Empire, controlling water became essential to feeding cities, supporting armies, and powering growing industries. Roman engineers built reservoirs, aqueducts, canals, bridges, and dams across Europe, North Africa, and the Middle East. One remarkable example was the Persia Dam in modern-day Spain. Built during the Roman period, its massive earthen embankment stretched for hundreds of meters and helped store water for the nearby city of Emerita Augusta, today's Merida. But the Romans had more than brute force. They understood how to work with gravity. They shaped dams with broad foundations and sloping sides so that the enormous pressure of stored water was transferred safely into the ground. They also developed a powerful construction material, Roman concrete. Made from mixtures of lime, volcanic ash, water, and aggregate, it allowed Roman builders to create structures that were incredibly strong and resistant to water. And their ambition went even further. At Cornalvo, also in Spain, Roman engineers constructed another enormous water storage system that has survived for nearly 2,000 years. The secret wasn't machinery, it was planning. They carefully studied the landscape, calculated gradients, selected durable materials, and organized enormous labor forces. The Romans had discovered a principle that would define engineering for centuries. You don't have to overpower nature, you have to understand it. But while Rome was mastering water in the West, civilizations farther east were developing their own extraordinary solutions. Before we travel farther east, here's a question for you. Which ancient civilization do you think was the greatest master of engineering? Egypt, Rome, Persia, or China? Tell us your answer in the comments. And if you're enjoying this journey through the engineering wonders of the ancient world, like this video, subscribe to Timeless Places and turn on notifications for more fascinating stories from history. Now, let's travel east. Thousands of kilometers from Rome, ancient engineers were solving the same problem. How do you control water without fighting against nature? In ancient Persia, engineers developed sophisticated systems for storing, transporting, and controlling water across some of the driest landscapes on Earth. One remarkable example was the Bandi Kaisar, or Caesar's Bridge, in modern-day Iran. Built during the Sasanian period, the structure combined a bridge with a weir and water control system, allowing engineers to regulate the flow of the Karen River. But Persia's greatest water innovation was often hidden underground. Ancient Persian engineers developed qanats underground channels that transported groundwater over long distances using a carefully calculated downward slope. These systems allowed communities to survive in environments where surface water was scarce. Then, thousands of kilometers farther east, ancient China produced an even more remarkable achievement: the Dujiangyan irrigation system. Created more than 2,000 years ago under the leadership of Li Bing, Dujiangyan did not attempt to block the powerful Min River with a giant wall. Instead, its engineers divided and redirected the river. A system of channels and carefully shaped structures allowed floodwater to escape while directing water toward farmland. The result was extraordinary. Instead of simply stopping the river, they made the river work for them. Dujiangyan has continued to function for more than 2,000 years, helping irrigate the fertile Chengdu Plain. Persia and China demonstrated two completely different approaches to the same challenge. One worked beneath the ground, the other reshaped the river itself. And both proved that ancient engineering was not simply about strength, it was about understanding water. So how did ancient engineers build structures that weighed thousands, even millions of tons without modern machinery? The answer wasn't one secret invention. It was a combination of simple technologies, used brilliantly. First came human organization. Ancient rulers could mobilize thousands of workers, farmers, craftsmen, soldiers, and specialized builders and organize them into teams. Then came levers. A simple wooden lever could multiply human strength, allowing workers to lift and position stones far heavier than one person could ever move alone. For larger loads, they used sledges, rollers, ropes, and ramps. A massive stone block could be placed on a wooden sled and dragged across prepared ground by dozens or even hundreds of workers. Lubricating the ground with water or other materials could reduce friction and make the task easier. But moving the stone was only half the challenge. Engineers also had to know exactly where to place it. They used ropes, plumb lines, water levels, measuring rods, and geometric calculations to establish slopes, angles, distances, and elevations. And they understood something modern engineers still rely on. The landscape itself is part of the machine. Instead of lifting everything vertically, ancient builders exploited hillsides, valleys, gravity, and natural slopes. Earth could be piled into enormous ramps. Water could transport materials, and gravity could move massive loads downward. Their machines were simple, but their thinking was sophisticated. They didn't need engines to accomplish extraordinary things. They needed mathematics, planning, thousands of coordinated hands, and generations of accumulated knowledge. That combination allowed ancient civilizations to reshape rivers and landscapes on a scale that still amazes engineers today. The most astonishing thing about these ancient engineering projects isn't that they were built thousands of years ago. It's that some of them are still here. The Dujiangyan irrigation system in China continues to manage water and support agriculture more than 2,000 years after it was created. The ancient Roman Proserpina and Cornalvo reservoirs in Spain remain remarkable examples of Roman hydraulic engineering. And beneath the deserts of Persia, ancient qanats still tell the story of communities that learned how to bring water to places where nature seemed to offer almost none. These structures changed more than rivers. They changed civilization. Reliable water meant reliable harvests. Reliable harvests meant larger populations. And larger populations allowed cities, kingdoms, and empires to grow. In other words, ancient water engineering wasn't simply about building dams. It was about creating the foundation for civilization itself. The builders didn't have computers to calculate every stress. They didn't have helicopters to survey valleys. They didn't have excavators to move mountains of earth. Yet through observation, mathematics, experimentation, organization, and generations of accumulated knowledge, they accomplished something remarkable. They learned to work with one of nature's most powerful forces. And perhaps that is the greatest lesson their dams leave behind. Technology isn't always about having the most powerful machine. Sometimes, it's about understanding the world well enough to know what you can accomplish with the simplest tools.
Every place has a story. Every civilization leaves behind a legacy. And every journey into history helps us better understand the world we live in today. If you enjoyed exploring with us, don't forget to like this video, subscribe to Timeless Places, and turn on notifications so you never miss our next adventure through history. Tell us in the comments, which place should we explore next? Until our paths cross again, keep exploring, keep discovering, and remember, history is never truly lost. It's simply waiting to be found. We'll see you in the next journey.